Hey there, folks. Welcome to another video. I want to see if we can put together just a quick one. We're going to put together the game Pong. I think it'll be fun. Shouldn't take us too long. And yeah, let's get cracking. Let's go with our straightforward story. We're going to be making this game in Pygame. And yeah, I'm sure it'll be fun. Pong was a fun game that I played before I was a baby, so I never played Pong. I used to play Arkanoid, which is another thing we'll make at some point. I believe this is like one of the very first photo games, so let's go ahead and put it together. Alright, the first thing we're going to go ahead for is we're going to import the Pygame module. Right. Once we've imported the Pygame module, we're going to create our little framework that we want to work off. So over here we're going to have our game classes. Okay. The next part of our structure we will go for is our utility game functions. The next section, once we've got our utility game functions, we're going to go with, because it's Pygame, we will initialize the Pygame module. Once we've initialized the Pygame module, we're going to need a couple of our game variables and settings. After we've done that, we're going to, once we've got our variables, we've got our game window. So we'll initialize our game, our game window. And then once we've initialized the window, we can initialize our game classes, which we'll be using. And then at the very end, we'll have our running the main game loop. So there's the basic structure of our game. Straightforward, classes at the top, utility functions, then basically the scripts that runs and starts the game for itself. So importing Pygame, the first thing we start off, let's get Pygame running. So we're going to say pygame.init. Okay, once we've got Pygame init, we're going to need our screen width, which is going to be equal to let's make it a big one, 1080. Screen height is going to be equal to 720 because we want the screen to be not too high, but we want it to be wide, like a table tennis table almost. All right. The next thing we're going to go is we're going to make our game screen under the initialize the Pygame window. Game screen is going to be equal to pygame.display.set mode. Display.set mode, and will be screen width. Oh, that's spelled wrong. Screen width, still spelled wrong, and screen height. Cool. Then once you've got our game window up and running, we're going to change the captions. We're going to say display.set caption, and it's going to be called Pong. Cool. Right, now we've done that, we've initialized that. Let's go down to our main game loop. So we're going to create a variable called run, which is equal to true, and while run is true, we're going to have our game loop starting. And under our game loop, we have for event in pygame.events.get if event.type is equal to pygame.quit. Right, run will then equal false. That will then break us out of our main game loop, and then we will have our pygame.quit. That will close down Pygame. Right, so that's our first section of our game set up. We should get a game window to the screen, and we hit an issue. Module Pygame has no attribute display. Of course, it doesn't have an attribute called display. It's display. Right. Let's try run it again. And there we have our game screen. See, it's the width is fairly long. We have our Pong. We're not going to change the icon. We're just going to do this. We're not going to import any images. We're just going to be working straight through out of Pygame itself. Fantastic. The next thing we're going to do is we're going to, I think we're going to then create a function which will which will then, hang on. I think the first thing we're going to do is we're going to create a function that's going to draw a line straight down the middle of the screen. That sets the game up into two halves, like a tennis court. And to do that, we're going to go after our utility game functions. We're going to define a function and draw game net. It's very simple. With an argument we're going to pass to it will be the game screen. We'll just call it window for now. Let's go to draw the net for the board. It's very simple, very straightforward. All we're going to do is call pygame.draw.line, and we're going to call it the window. We're going to make it white, so 255 by 255 by 255, and we're going to say, okay, well, it needs to be in the middle of the screen on the X position, so we're going to go screen width divided by 2, and then the Y position, the first part of the line will be at position 0 for Y. The end part of the line is going to be still screen width divided by 2, and then it's going to be screen height. My screen width is spelled incorrectly. Screen width, screen height. Then that'll be it, right? We're not calling this function anywhere. We need to call this function, which means we actually need to create a function called update game screen, because we're actually not drawing anything to the screen. To do that, I call function. We're going to call it define update game screen. And we're going to do that to the window. Right. So let's put a comment here. So updates game screen, display screen. All right. And in this function, we're going to pass window.fill right at the beginning. And we're going to fill it with black, the color black, so 0, 0. All right, and then below that we just need to call the pygame.display.update method. Right, we're still not calling this function anyway. Window.fill, we need to directly underneath that, we're going to call draw game net. Of course, was the window. Okay, we're still not calling it. Let's over here at the bottom, we're going to say, what did we call that? We called it update game screen, and then the window will be game screen itself. So we should now have a line down the middle of our screen, and there it is. That took a long time to load. Let's try that one more time. There it is. Fantastic. That's fantastic. Update the game screen, window.fill, draw game window. Okay. Okay. Alright, let's just make another space there. Okay, so we've now created basically our playing board. Next thing we need to create is our game classes, our pedals. Let's start off with the pedals. So the first thing we're going to do with the pedals, we're going to go under game classes. Right at the top, under game classes, we're going to call a class player pedal. Okay, we're going to do our under init method. So it's going to be diff under underscore init under underscore self and player, so we know which player it is. And we're going to go self.player is equal to player. Then some of our attributes, the attributes we're going to go with. Okay, we're going to have two pedals. We're going to have the player one pedal, and we're going to play two pedals. And in order to differentiate the two, we're going to give them two different colors. Okay, so I just want to, instead of us having to draw out, write out 255, 255 every time, we're going to go down to our game variables. And we're just going to define the variable color white, make that 255, 255, 255. And directly below that, we're going to define a color red, and we're going to make that 255, 0, 0. So now we've got the two color variables, white and red. Okay, so we've got our player, and under our player, we're going to go with self.color is equal to white. If self.player is equal to 1. Else, right, it'll be red. Okay, so self.color is going to be white if self.player is equal to 1. else it'll be red. The other thing I want to do, let's just, while we're busy here at the top here, we're going to go down to define our draw game net window. Okay, so what we need to do is here where it says 255, 255, 255, we're going to just change that to white. It's going to save us a lot of time going forward. All right. Then the next attribute we're going to add to our player class, we're going to call it self.width. Width, and that's going to be equal to 10. So our pedal is only going to be 10 wide. Self.height. Our pedal is then going to be 150 pixels long or high. Then we're going to give our starting position for our pedal. The starting X is going to be equal to 50, which is on the left-hand side of my game screen. If it's player 1. If it's player 2, it's going to have to be on the other side of the screen. So we're going to say it's going to be self position X, or the top left corner of the rectangle will be position X, that's 50. If self dot player is equal to 1. Else, the position will be the screen width, which is on the opposite side of the screen, minus 50, because it's working backwards to the left now, minus self.width of the player paddle. Okay. Then we're going to move forward. We're going to say self.pos y will be equal to screen height. Self.pos y will be equal to screen height divided by 2. So that's in the middle of the screen, minus self.height divided by 2. So what that does is the y position of the rectangle will be in the middle of the screen, moved upwards by half of that rectangle. Okay. Then we're going to go ahead and create a rectangle, an image rectangle of our pedal. So there we're going to go pygame.rect. And the coordinates for this will be, the attributes for this will be the arguments, my apologies, the arguments will be self.pos x, self.pos y, self.width, self.height. So now we've just created a rectangle that goes around our paddle, which we will be drawing to the screen. The last two attributes we're going to create self.val_y, which for my velocity will be for moving the paddle, and then my self.score, which will be equal to 0. And that is all the attributes that we'll be needing for our player class. So all of these attributes has all got to do with actually drawing the rectangle of the pedal to the screen. And as you go through the methods now, you will see what I mean. Let's go ahead and create the first method. The first method we're going to create is going to be the draw method. Def draw. It'll be self, and then to the windows, the argument will pass to it. Comment, draw the player pedal to the screen, I think. Right, we're going to draw the pedal to the screen. Pygame.rect. No. Pygame.draw.rect. So we're just drawing a straightforward rectangle to the screen. Will be to the window. The color will be self.color. And then the rectangle, which we've already got from creating the self.imageRect. All right. So let's go down here. Initialize game Pygame module, game variables. Here's initialize our game classes. If we go ahead and create player 1 as an object, player pedal, and the argument will be 1, and we create player 2 is equal to player pedal, and that'll be player 2. We should get these objects drawn to the screen. No, we won't yet. We've got to go to our update game screen window. And over here, we're going to go player1.draw. Okay, and we'll be to the window. We're also going to player 2.draw, and that'll be to the window argument. So that's under my update game screen. We've now included the player 1 object and the player 2 object to be the draw methods to the screen. We should get 2 pedals drawn to the screen. Hey, what do you know? It almost looks like a soccer field. We've got the white pedal because he's player 1. We've got the red pedal because he's player 2. That's exactly what we wanted when we called our methods. Fantastic. The next thing we're going to do in our player class method is we're going to put in some movement actions for our pedals. So in order to move our pedals around the screen, we're going to create a move method. Let's create a move method first. So here, just above our draw method, we're going to define another method called move. Straightforward, don't need to give it any fancy names. So we'll give it a move method. The argument straightforward is just self, and we're going to say moving the pedal up and down the screen. Straightforward, nothing special. And in order to move it, well, in order to move the pedal up and down the screen, we're going to have to change the position of the image rect Y position. And to move that, we're going to make it self.pos Y plus self.val Y. Right. Now, in order to do that, so we're going to be changing the self.val Y variable or attribute. To do that, we're going to go create another method. We're going to create a method called direction. Okay, self.direction, and action is an argument we're going to pass to it, and increasing or decreasing the Y position of the player pedal. Right. So if the action is equal to up and self.image rect 1, which is the Y position of the rectangle, is greater than 0, well then self.val Y will be increased by 5. Will be increased by 5. Now if the action is equal to down and self.image rect Y position plus the self.height, meaning now we're now looking at the bottom of that of the panel rectangle, is less than or equal to the screen height. Then self.val Y will be plus equals 5. I've got them both moving in the same direction. That one will need to be a minus. So what we've done now is we've created a direction thing, a direction method, which changes our self.val Y variable value. It's currently set at 0, which is in the middle of the screen. And as we hit the button to move upwards, that val.y position is going to increase or decrease by -5, -5, -5, -5. We're then taking that -5, -5, -5 position of the velocity attribute and adding it to our regular position y, and that'll give us the new position of our rectangle for the paddle. It's hard to explain. I hope you can follow along with that. We're going to now include it into our game. So before we include our game, this is our action. Once we've done our action, it increases our attribute. We need to find a way to call this move method. And I think the best way to call that move method will be underneath our draw method. Self.move. Alright. So every time that gets drawn to the screen, it does a check to check where is the position, it updates the position of my rectangle. Right, so we're going to go back down to our main game loop. And over here we're going to add a little bit of code to handle the movement of our paddle. Alright, so we're going to go add a line there. We're going to go key presses is equal to pygame.key.get pressed. Right, that's our, and then if key presses, and then the first one is pygame.k_w right? Player 1 dot direction, and we're going to pass it the up argument up. Okay, then we're going to say if key presses Pygame dot k underscore s, right? Then player 1 dot direction. Come on, spell properly. Direction will be down. Okay, so we can just quickly test that out on the first player, which is W and S is our keys that we're using. If I hit the W button, this paddle should move upwards. Sure, that's moving very fast. That's very fast. Okay, we will fix that in a moment, but obviously now we don't have anything for the red character, player 2, but we'll add that now. So we're just going to go ahead and copy this little bit of code, paste it directly underneath, except now we don't want KW, we want the up arrow and down arrow, and then it's not going to be the player 1 object, it's going to be player 2 object. Alright, if we run this again now, we should get our player 2 object to move, and he's moving. And you'll see, because we put in a check to make sure that our paddle, the top left, the top X, the top Y position of our paddle is at 0, it doesn't go past. And if our bottom Y position of our paddle hits the bottom, it doesn't go past. Obviously, we don't have a left and right movement. And we have that, and we can have them both moving at the same time, which is, and they move independently, which is fantastic. All right. The last thing we need to check on our player paddle, we don't on our player paddle, it's just the way the paddles are moving so quickly. We're going to add a clock quickly to our game. Here in our game variables and settings, I just want to add a variable for the clock. We're going to go clock is equal to Pygame dot time dot capital letter clock, right? And then in our main game function, underneath our update game screen, we're going to call clock dot tick, and we're going to make it 60 frames per second. That's all we're going to do. So that should make our paddles move a little bit more smoothly. Yeah, slow, but they move better. They're moving better. It adds more challenge to the game. Cool. Right. We've now got our player class, which is handled. Our player class has been handled for both players. It's already been put into the game. It's fantastic. It's working. The next thing we need to do is add to our game the ball. We need to draw the ball to the screen. First, we need to create a ball. Then we need to draw the ball to the screen. Once we've drawn the ball to the screen, we then need to move the ball. After we've moved the ball, we then need to check for collisions of the ball against the top and the bottom of the game screen, as well as collisions against the game paddles, and then also to handle what happens if the ball leaves the sides of the screens. It sounds like a lot. It's a fun little bit to do. It's not going to be too complicated. There's only one section that's got quite a bit of code under it, but once we get to it, we'll go through it slowly. So underneath our player classes, we're going to create a new class called ball, and we're going to create our init method self. We're not going to pass any variables because it's going to be starting off straight in one position. So our self.pos x is going to be equal to 65, and our self.pos y is going to be equal to our screen height divided by 2 minus 15. And then we're going to create a little rectangle for this ball. Self.ball rect is equal to pygame.rect.rect. And for that, it's going to be self.pos x, self.pos y. Sorry, I just need to correct that spelling there. Pos x, pos y. Width of the rectangle is going to be 30. Height of the rectangle is going to be 30, so that makes it like a square. Okay, then we're going to create an attribute for the ball, self.direction x, because the ball moves in x along the x-axis at a speed of 5. And then we're going to create a self.direction y attribute for the ball. When it moves up or downwards, upwards or downwards angle, we're going to set that at 0, so it's always going to be running, it's just going to be moving in a flat angle for the moment. That's everything we need to initialize our ball. The next thing we need to do is draw our ball to the screen, so we can create a method, diff draw self, and we're going to give it an attribute called window, and let's just give it a little description. Draws the ball to the screen, then calls the ball move method as well. We're going to handle the ball, the movement, almost the same way as we do with the paddle movements. Okay. So the first thing we need to do is we need to draw the ball. So Pygame, draw circle, because the ball is a circle, and we're going to draw it to the window. We're going to make this one the ball, no, not window. Sorry about that. Yeah. So Pygame.draw.circle, we're going to draw it to the window. The color of the ball is going to be 255. Then we're going to have it as a self.ballRect 0 plus 15. Self.ballRect y position 1 plus 15 and 20. Okay. When you're creating a circle, you've got your which screen you're going to draw the circle to, the color of the circle. Then it's the x position and the y position of the center of your circle, and then it's your radius, which we've got at 20 here. Okay. If I call the ball, let's go down to where we initialize our player objects and game classes. So ball is going to be equal to ball, right? And we need to call the draw method underneath here. So here under the player, we're going to say ball.draw self window. So the ball object should now appear on the screen, and there it is. There's our ball. We have a ball object. Obviously it's not moving, it's independent of my player paddles. It's just sitting there on the door. Alright. What we want to do now is we're going to add some movement to our ball. So in order to add some movement to the ball, we need to create the method called move, just like we did under the play classes. Oh, I wonder, no, I couldn't really have inherited. I could have, but it would have just made things complicated for myself. Move, self, okay. So here we go, we're going to moving the ball around the game screen. We're going to move the ball around the game screen. So the first thing we're going to do is we're going to check the position of our ball. Okay, so the first thing we're going to put in, if self.posX is less than the screen width divided by 2. So that means if the ball is on the left-hand side of the screen when the game starts, we're going to tell self.ballRect position x plus equals self.direction x. Okay. What that's doing is checking if the position of my ball, the x position of my ball is on the left-hand side of the screen of the half of that game net, then my ball position on initialization must be self.direction x. Now my direction x is 5, which means if the ball is on the left-hand side of the screen, the x position is going to be increasing by 5 every single time this move method is called. And we need to call this move method in our draw method because we want it to be called regularly. So in my draw method, I'm going to go in there and I'm going to say self.move And if I run this method, now my ball should be moving to the right of the screen. And there she goes. And she's just going to carry on going because we're not doing any collisions. But that's what we were looking for. We wanted our ball to move. And there she goes. As soon as the game starts, that's just how we've made it at the moment. The ball goes off to the right. Right. Now, the next thing we want to do is we want to check to see. Let me just give this a thought. We're now going to check what we need to put in now. So we need to check for collisions. We need to now check for ball collisions if it hits the paddle. Okay, so we're going to go down to our main game screen. And I think we're going to put it over here. Oh, there, okay. Okay, so in our main game loop, we're going to add two checks. So we're going to say if ball dot ball rect dot left. Okay, so if the left hand side of my ball, you know what, I think this will be easier. Let's just cancel that quickly. Let's go back up to our ball, our draw method for our ball, and let's just quickly add a square box so that we can see exactly what's going on. All right, where's my draw method for my ball? There. So we're going to Pygame dot draw dot rectangle, draw to the window. We're going to make it white. Self dot ball rect, which is the rectangle we created earlier, of 1. If I run the game again, now we will see a little rectangle square. There's a square surrounding our ball. That's what we want. Okay. That'll make this easier for us to understand. So we're going to handle collisions by handling the square of the ball, the square that we've created that's inside of our ball. That's going to be our little collisions detector. So if we go down to our main game loop, over here, we're going to check for collision of if the ball dot ball rect dot left. So if the left hand side of the little square that you saw is equal to my player 1 dot image rect, the right hand side of my paddle, and ball dot ball rect dot bottom. So the bottom of the square of my ball is greater than and equal to player 1 dot image rect dot top. Player 1 dot image rect dot top. Right. And ball dot ball rect dot top. So the top half of my square around in my ball is less than and equal to player 1 dot image rect dot bottom. That is a mouthful. Let's go through it line by line quickly. Let's go through it one by one. So if my ball, the left hand side of my ball is at the same, let's try this again. If the x position of the left hand side of my ball is equal to the right side, the x position of the right hand side of my player's paddle, right? So if they're on the exact same x axis, right? And if the bottom y axis of my ball, so the bottom y axis of the square in my ball is greater than the top of my player paddle. Remember, going Pygame, the screen starts at the top of 0 and it moves downwards to increase. So if the bottom of my ball is greater than the top of the paddle, and the top of my ball is less than the bottom of the paddle, that means that the ball will then be colliding with the player 1 paddle. That is quite a mouthful. Okay, I know, I'm sorry. I'm really trying to make that explain better. I'm just going to click here by the end. I'm just going to let it drop down to the second line, and I'm just going to put a little backspace there so that the code is continuing on the second line, because that's getting quite hard to read. If that's the case, well, basically we just want the ball dot direction x to just flip. So if it's moving to the right, if it's going 5, 5, adding by 5 every time to the right, once it hits that paddle, it must then, the ball direction must then switch, must then become negative 1, 5. Ball direction multiplied by negative 1. Yeah. Sure. I really hope you're able to follow me that. Let's go through it again. The left-hand side of the square of my soccer ball, of the Pong ball, must be equal to the right-hand side of my player 1 paddle. It means that they are then basically touching. And the bottom of the ball square must be greater than the top of the Y paddle, the top of the Y of the player 1 paddle, and then on the Y coordinate, and then the bottom of my ball. I said the bottom of my ball. The top of my ball must then be less than the bottom of the player 1 paddle. If that's the case, that means my ball has then connected with the player 1 paddle, and then the ball direction must then flip to, if it's negative, it must flip to positive. If it's positive, it must flip back to negative. I'm just going to take this little block of code, and I'm going to copy it, and I'm going to paste it right below it. And the only thing I'm going to change is I have to go change now, because now we're doing it for the player 2 paddle. So if the ball.ball.rect.left, that must be right, is equal to player 2.image.rect.left, so the left-hand side of the player 2 paddle. And if the ball.rect.bottom, which is correct, is greater than or equal to the player 2 image.rect.top, and ball.rect.top is less than or equal to, oopsie, what happened there? No, page down. Sorry about that. If the ball.rect.top is less than or equal to player 2 is bottom, then my ball direction must then flip again. So what we should see now is the Pong ball bouncing back and forth on the game screen. Let's run it. Let's see if we've got it working. So the ball's going. It should bounce back. Yeah, it bounced back. And it should bounce off the white paddle. It's done that. If I move the red paddle out the way, it'll go past. That's fantastic. It's working. Wow, hunky days. The next thing we want to do is we want to make the game a little bit more interesting. We don't just want the ball going back and forth in the middle of the screen, because the only way you lose is if you move your paddle out the way. So we wanted the ball to move at various angles depending on where the ball hits the paddle. So if the ball hits like between the middle and the top, the ball should shoot at an angle upwards. If the ball hits the paddle between the middle, halfway and the bottom, it should at an angle downwards. That's what we're going to add right now. And in order to do that, I think I built it so we will be doing it within the ball method instead of doing it anywhere else. And we're going to create a fairly large method right now, which is going to be fun. I hope you're able to follow along. I'll try and go through it piece by piece so that you'll be able to copy it along as you go through it. In my ball class, underneath my move method, we're going to create a method called paddle angle. Sure. And all we're going to do is we're going to add an attribute, an argument called player. And the description, we're just going to add in checking the ball collision with the paddle and setting angles once off the paddle. Okay, that's not a very good descriptor. That's the best I could come up with. Right, so now we're going to have a bunch of if statements. Okay, so follow along with this. I'll try and explain it as we go through. So now we're going to look at if the self.ballRect.bottom, right, is greater than or equal to the player argument dot image rect dot top. Right. So if the bottom is greater than or equal to the player image dot rect top, so it's the absolute top of the paddle, and self.ballRect.bottom is less than or equal to the player dot image rect dot top plus 10. Okay, so basically we're just looking at the top 10 pixels of the rectangle, just the top 10 pixels of the rectangle. If the ball hits that, we want the ball's self dot direction y to change to -5. Okay, so if I go into my game, and we'll see the ball start moving across the screen. If I move this pedal down so it hits the top, it's going to be very difficult. Hopefully I've got it right there. If it hits that, it should, no, it's not doing anything because, of course, that should be closed. Let's close that. We're not calling the pedal angle method anywhere. We should be calling the pedal angle method down at the bottom here. It's alright. At the bottom in our main game loop where we're checking the S collisions, ball collision, there we should be calling ball dot pedal angle, and it'll be player 1, which would be player 1. And then in our player 2 check, we're doing ball dot pedal angle player 2. Okay. So what should be happening now is now it should run. It should work now. It should work. It should work. We're now calling that method. If I get this thing to go down, oh no, we're still not calling. It's still not working. Why is it not working? Still not working. Why is it not working? My move method. Where's my move method? Oh dear, we're not changing our Y position at all in our move method of the ball. So back to our move method. Right, simple little line we forgot about. Self.ball rect and 1, because that's the position of our Y position. It's going to be plus equals self.direction Y. Self.direction Y. So self.ball rect 1 is plus equals self.direction Y. Right, if we move it now, it should work just fine. Now it should work. It should work. Oh, let's try again. Come on, it should work. Come on. Oof. That's what we want. Of course, the ball goes out the screen, but we'll sort that. Do you see the angle there? So that's at position 5. That's perfect. It works. This little section here, this is going to be fairly quick to do. I'm just going to copy paste it a few times. So we're going to have -4, -3, -2, -1. Okay, so if ball, okay, so on the second if, we now need to add that 10, and we're going to make 20 there. Then on the third if, after the top, we're going to add the 20 pixels, and at the end, we're going to make it 30. And then at the top, we're going to say plus 30, and we're going to make that 40. Then we make it plus 40, and we make the end there 50. Okay, and then our direction is -5 is going to be -4, it's going to be -3, it's going to be -2, it's going to be -1. Right. So that's like various stages of our paddle. So as you can see, if we go into our paddle, if I have it hit like there, it's just going to come straight back. But if we have it hit there, it's going to bounce at that angle. Oh, we missed it. Okay, so it's at various angles. At the Y angles, Y will move at various angles. So the Y will go stronger. Hang on. So it'll climb slower the closer to the center of the paddle the ball hits. All right. Then we need to do 5 more checks for the bottom half of the paddle. So for the bottom half of the paddle, it's going to go if self.ballRect.top for this ball is less than or equal to player.image rect dot bottom and self dot ball rect dot bottom is greater than or equal to player dot image rect dot bottom minus 10 pixels. Okay, then we're going to say straightforward self dot direction y will then be equal to 5. So now if the ball hits the bottom lowest part of the paddle, the self direction will then equal to 5. So we're going to take this same piece of code, just like we did above, and we're going to copy it down. Right, that's 4, 3, 2, 1. Okay, so here on the first if, we're then going to say minus 10, and then this is going to become minus 20, and over here is going to be minus 20, here is going to be minus 30, here is going to be minus 30, hey, what's going on here? Come on, let's keep it looking the same everywhere. Then over here is going to be minus 40, then over here it's going to be minus 40, and over there it's going to be minus, no, don't do that, minus 50. Okay. And then our self directions were 5, we want it to be 4, 3, 2, and 1. And then lastly, if it hits the center of the screen, if you hit it in the middle of the paddle, we want to just stay the same. So if self dot ball rect dot center, if the center of the ball, the y position of the ball is greater than or equal to player dot image rect dot center, which is the minus 10 pixels, and self dot ball rect dot center 1 is less than or equal to player dot image rect dot center, whoopsie, center 1 plus 10. Okay, self direction. Okay, go, I'll charge the batteries. Take it outside, I'll charge the batteries. Direction y will then be equal to 0. So if it hits the center of the paddle, the ball then must reset and just fly across the screen at 0, at the 0 y angle. Okay, so we call them paddle angles. So now we've got that running, so that we should have the ball hitting at different areas. So if the ball hits my red paddle there, it should shoot down. This is going to go out the screen. But that's working. So now we're going to go to our self.move method. We're going to check for the Y collision on the top and bottom of the screen. So on the top of the bottom of the screen, if self.ballRect.midTop, right, is less than or equal to 0, or self.ballRect.midBottom is greater than or equal to the screen height, self.direction y, self.direction y will then be equal to self.direction y multiplied by -1, because we just want it to flip, move in the opposite direction. All right. So what that should do in the move method is then if my ball hits the top and bottom of the screen, it should just bounce. So let's make it hit the bottom of the screen. Dum, dum, dum. Oh, it bounced. That's what we wanted. But now the ball's just carrying on moving forever. Okay, let's let it go, let it go, it's going. Dum. We want it to hit the top of the screen. Dum, dum, dum. Bum, 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 bum. That seems to be working fairly well. Cool. Our ball method is very nearly, our ball class is very nearly finished. So what we need to do now is we need to create a function to handle if the ball reaches the ends of the two sides of the screen. And if the ball hits either side of the screen, a player should have their score increased. We need a way to show that score on the screen. And then we need to reset the round. Everything needs to be reset in order for the game to continue again. So in order to do that, we're going to create a couple of utility functions. I think the first one we'll create is the update the players. We're going to update the player score. There are utility game functions. Above my update game screen, below my draw game net, let's call a function called update player score. It's fairly straightforward. And we're going to use the player as the argument. All right. The comment's going to be increases the player score and resets the game for a new round. Okay, so that's what this function is going to do. So first thing we're going to do is we're going to check the player.score and we're going to increase it by 1. Straightforward, easy enough. We need to create a separate function called reset round, which is going to be a fairly large function, but we'll be able to handle it fairly quickly. And we're going to call it here in this. We're going to say reset round. Okay, reset round, and possible. So before we do that, let's go create the function. The function reset round, player. Okay, in the reset round, there we go. Resets the pedals and the ball and starts the game anew. Okay, that's a spelling error there. Let's fix that quickly. Resets. Okay. First, we're going to go player 1 dot val y attribute. It's going to be reset back to 0. Player 2 dot val y. It's going to be reset back to 0. Ball dot ball rect position x is going to be reset back to 65. Let's just go to the ball. I'm creating a ball class. No. Okay, wait. So it's going to be reset to position 65, dependent on. So the position of the ball reset after the game resets will be dependent on which player scored. 65. So if player.player, right, is equal to 1. So if player 1, the ball will be reset to 65. If the argument player is player 2, the ball will be reset to screen width minus 50 minus player dot width minus 40 for the ball diameter, the full diameter of the ball that needs to be properly screen width. Okay. Then ball dot ball rect 1. The center position of the ball will be screen height divided by 2 minus 50. Alright. And then we'll have the ball dot direction. For the ball direction, the y direction must be reset to 0. Then the ball dot direction x will be equal to 5 if player dot player is equal to 1. Else it will be set to minus 5. Okay. And the last thing, I'm just going to have the game hang for a few seconds. Hang.pound.wait just for 3,000 milliseconds, just to give the guy a chance to see the game reset. Okay. So the reset round, and then we're going to go call that reset round after we update our player score. So reset round, and we pass it on player there. So we call this method up here, where we do the check for our if x, our ball position in our move function, if the ball moves out of the screen. So if self in my ball class under my move method at the bottom of it, I'm going to if self dot ball rect 0. What's the matter? If self dot ball rect 0 plus 30 is less than or equal to 0. Okay. And we're going to call update player score, and the player will be player 2. Right. If self dot ball rect my x position minus is greater than or equal to my screen width, update player score, and will be player 1. Cool. If we run this game now and we let the ball go past, the game should reset. I can fix it now, I told you.
What did it say again?
I can fix it now. There we go. Yeah. So the next thing we need to do is we just need to add 2 more functions to finish off the game. And that's just drawing the text to the screen. Okay. So under our utility functions, our utility game functions, under update player score, we're going to create a quick function called diff text to screen. And we're just going to pass it a message, whatever it is that we want to pass to the screen. Comment utility function to draw the text to the screen. Okay, I'm going to go with font. Create a variable called font. We're going to say pygame dot font dot sys. Why is it not? There we go. Pygame dot font dot sys font. And the name is going to be, we're going to call it comic. No, just text. Comic sans. And it's going to be, the size will be 22. Right. Now my message is going to be equal to font dot render. And what it will be the message that we pass to it. It'll be 1, and it's going to be in white. Okay. And then we will return the message. Okay, so that's our utility function. Once we've got our utility function for text to screen, we then want to actually call it under my update game screen. Underneath in my update game screen function, underneath ball.roll method, we're going to say player 1 score is equal to text to screen, and the message is going to be special formatting if player 1 score, and then in special brackets player 1 dot score. Okay, and then we need to window dot lit that to the screen, player 1 score, and the x and y position we're going to go with 20 and 30. Right, if we go ahead and run that, we should get the player 1 score on the top left of the screen. There we go, and you can see it's there. I just need to fix that spelling error. Okay, player 1 score. There, that must be a small c. So if we're playing and we let the red paddle move out the way, the score should move upwards. That's what we want to see. Now we want to add a player 2 score on the right hand side, and the game will basically be done. So we just take this little block of code, we can copy it below it, we can say player 2 score is going to be text to screen, that's going to be player 2, and we want to pull out the player 2 object or score. That's going to be player 2. Alright, and then the only thing different is in my X position, we're going to go with our screen width minus 20 pixels minus player 2 score dot get width. Alright, if we run our code, we run the Pygame function, we run our code, there's our game, we have the pedals moving up and down. We want to hit that pad. The ball is going to go upwards. We want player 2 to score a point, so we're going to move player 1 out the way. Ball goes out the screen. And resets. Player 2 score is updated. Come on. Player 2 score is updated. Player 1 score is 0. Player 1 moves away. Player red moves out the way. Player 1 score should be updated. So now it's 1-all. Right. That's it. That's our whole game in a nutshell. That was Pygame, Pong in Pygame. I hope you enjoyed this little video. It was a lot of fun putting together. I spent quite a bit of time trying to figure out how I'm going to match within the pedal where the ball's hitting and what position the ball is hitting. I completely forgot that you can use like a range within an if statement. So if it's within this point and within that point, it would work. So I, basically just face-palmed myself when I realized how silly I was being. Once again, thank you very much for joining me on this video. I hope you had a good time. I hope you followed along. I hope it wasn't too complicated. And I hope you managed to get it done the way I did. See you guys in the next one.